Welcome back, everyone. This set of videos is going to be part one of three for our Chapter 10 section on conic sections, and we are going to start with parabolas. And as you can see here, if you take a cone and you slice it a certain way, you can get different shapes. So this part one, we're going to deal with parabolas and how we can use what's called HK form and go with the different properties that go with it, and how we can graph parabolas simply using this form. So let's take a look. So we're starting off with this formula. This is what we start with right here. Okay. So we start with HK form right here. As you can see, we have an H and we have a K. That's pretty much how all the conics are going to go. So if we have x minus h squared equals 4py minus k. So my pre-calc class has their formula sheet that has these examples. So if you follow along with that, for those of you that are not in my pre-calc class, you can just use these examples on a scratch sheet of paper to see how we're going to graph these. Now they're always going to be in this form, this HK form. We're not going to dive into if they're not, how you put it into HK form. This is just the basics of it already being in HK form. So as you can see, we have x minus h, 4p, y minus k. So x minus 3. So this winds up being our h right here. And then 8, and then y minus 2. This winds up being our k right here. Every conic we do starts with finding h and k. So for our sake here, for parabolas, the HK represents the vertex. So we have 3, 2 that represents our vertex. Now, how do we know if this parabola opens up or down? Well, we have to take this value right here, this 4p, and we have to set it equal to what's in front of the parentheses. So we're going to take 4p and set it equal to 8. And you usually have a pretty simple algebra expression to solve here. Divide by 4 on both sides, and you get p is equal to 2. So knowing that p is positive, it's going to open up. P is negative, it opens down. We got p equal 2, so we know it opens up. So we're just going to draw a nice, easy parabola. We don't get into the technicalities of how wide or how skinny the parabola is. We just draw a nice open parabola. Don't draw an absolute value. Just make sure we have a nice curve here that goes with it. We have three main characteristics that go with it. The first one is the axis of symmetry. Pretty much what you remember from geometry. A line of symmetry goes right through the middle, and we have the mirror image on each side. We have it as x equals h. So it's a vertical line because we have x equals. Now we already know what h is. H from the beginning was 3. So we have x equals 3. We draw that with a dashed line or a dotted line that goes right through it, and we label it AOS. The next thing is our focal point. I tell my classes, make sure that your focal point is on the inside and it's on the AOS, the axis of symmetry, because if it doesn't fall on that, you did something wrong. Pretty simple to follow along here. We have h. H in our problem, again, was 3. And then, comma, k plus p. K was 2, and p was 2. All right, so we're going to have 3, comma, 4. And as you can see, it's inside the parabola right here, and it's on the axis of symmetry. Our directrix is always outside the axis of the parabola, and it's always pretty much perpendicular to it. So we have a horizontal line here because we know it's y equals, and we have k minus p. So k was 2, minus p was 2. So we're going to have y equals 0. So y equals 0 is right there excuse me, on the x-axis, and we know we're done. That's pretty much how we're going to label everything. Now, one way to check is this p-value. Whatever the absolute value is of that, that's the same distance from the vertex to the focus and from the vertex to the directrix. So if you actually count this, 1, 2, and 1, 2, we have that same distance going from each one of them. All right, let's look at the next example. Here we have x plus 2 squared equals negative 12, y minus 4. So because we see plus, a lot of times, again, people like to think opposite because x plus 2 is the same as x minus a negative 2. So we know that x minus h, so that h has got to be that negative 2. And this is already of the form y minus k. So we're going to have negative 2, 4. And we plot our vertex right there. Again, which way does it open? Well, we got to take 4p right here and set it equal to the number that's in front of the parentheses. So 4p is equal to negative 12. P's got to equal negative 3 when we divide by 4. This way, because it's negative, we know it opens down. So we're going to draw an upside down parabola. X equals h for our axis of symmetry. H again in our problem was negative 2. So x equals negative 2. That's a vertical line, dotted or dashed line labeled AOS. Our focal point is h comma k plus p. So h again in our problem was negative 2. K was 4. And then p was negative 3. So that gives us 4, 1. Or excuse me, negative 2, 4 plus negative 3. So negative 2, 1. There's our focal point. Again, on the inside, just like we said on the last one. And our directrix, y equals k minus p. Well, that was 4 minus a negative 3. So we know that back-to-back negatives, we got y equals 7. And there again is our directrix on the outside. If I take the absolute value of negative 3, that's 3. So if I count from the vertex, from the vertex to the directrix, that's 1, 2, 3. And from the vertex of the focus, 1, 2, and 3. I'm good there too. All right, so those were up and down. So now, what's the difference if it's up or down versus left or right? Well, if we look at the next example, here we go. Y is being squared. So when y is the first variable, we know this is going to be a left or right. Now, the one thing we got to remember is that x will still go with h and y will still go with k. So you can't mix them up. So our first vertex that we're going to start with, h and k, there's our h, there's our k. So we're going to have 5, 1 as our vertex. So now all of everything else has to change slightly because it's a sideways parabola. So now if p is positive, it opens right, p is negative, it opens left. But we still do the same thing here. We're going to take 4p, set it equal to 16. So 4p is equal to 16. Therefore, p's got to be 4 when we divide. And because that's a positive number, we're going to open to the right. So I draw a nice easy parabola that opens to the right. Now, on the previous ones, our axis of symmetry was a vertical line. Now our axis of symmetry is a horizontal line. So we are going to have here y equals k. So again, k in our problem was 1. So we're going to have y equals 1 as our axis of symmetry with a dotted or dashed line that goes through there. Our focal point changes as well because we are on this horizontal line. So now I have h plus p. So h was 5 plus p, which was 4, comma k, which was 1. So that gives us 9, 1. And we are on the inside there. Okay? And again, 9, 1 comes from the origin. Directrix is equal to now a vertical line. X equals h minus p. So again, h was 5 minus p, which was 4. So I'm going to have x equals 1. There's our vertical line. And you have the same check. If you take the absolute value of p, absolute value of 4 is 4. We go from the vertex, 1, 2, 3, 4. We're in the right spot. To the directrix, keep doing that. 1, 2, 3, and 4. We're right there. So that's a parabola that opens to the right. And our last example, guess what? It's going to open left. So again, start with our vertex, remembering that h and x go together, k and y go together. So we have negative 4 and negative 1. Again, thinking opposite there. There's our vertex. We're going to take 4p, set it equal to negative 4. So p is going to be negative 1. So we know that's going to open to the left. Axis of symmetry is y equals k. K was negative 1 in our problem, so we got y equals negative 1. And again, make sure you're putting y equals, because it is an equation of a line. Focal point, h, negative 4, plus p. P was negative 1, comma k. All right, so that's negative 1 there. So we are going to have negative 5, negative 1. And there's our focal point on the inside. X equals h minus p. So negative 4 minus a negative 1. So that'll give us x equals negative 3. And again, your check. Absolute value of negative 1 is 1. So from the vertex to the directrix, 1. vertex to the focal point, 1. We did it right, and we know we're opening to the left. So there's 4 speedy examples there of parabolas already in HK form and the properties that follow with it. Thanks for tuning in, and check out video number 2 for conic sections that are going to do circles and ellipses.